Every civilization that has ever existed has collapsed. Every single one. The Sumerians, who invented writing and built the first cities, gone. The Egyptian dynasties, which endured for 3,000 years, gone. The Roman Empire, which dominated the Mediterranean world for centuries, gone. The Maya, the Khmer, the ancestral Puebloans, the Easter Islanders, all gone. This isn't ancient history. This is pattern recognition. And the pattern suggests something deeply uncomfortable about our own future. Because we are a civilization, a complex, technological, global civilization. And if history is any guide, we are temporary. We will collapse. The only questions are when, how, and whether we'll see it coming. Tonight, we're going to explore why civilizations don't last, why complexity becomes fatal, why technological advancement doesn't guarantee survival, and why the logic of collapse suggests we might be living in humanity's final century. This isn't pessimism. This isn't fear-mongering. This is mathematics. This is archaeology. This is the accumulated evidence of 5,000 years of human civilization, all pointing to the same conclusion. Nothing lasts forever. Not empires, not cultures, not ways of life, and probably not us. Let's start with a definition. What do we mean when we say a civilization collapses? We don't mean that every human dies. We don't mean that all knowledge is lost. We don't mean the complete extinction of the species. Collapse means something more specific. It means a rapid, involuntary simplification of a complex society, a loss of political unity, a decline in economic sophistication, a reduction in population, a decrease in the ability to maintain infrastructure, produce food, provide security, and transmit culture. Collapse is when the systems that define a civilization stop working, when the roads aren't maintained, when the trade networks fail, when the city's empty, when literacy declines, when technological knowledge is forgotten. It doesn't happen overnight, but it happens faster than growth, much faster. The Roman Empire took centuries to build. It collapsed in decades. The classic Maya civilization developed over 1,000 years. It collapsed in less than a century. The Bronze Age civilizations of the Eastern Mediterranean thrived for generations. They all collapsed within a span of 50 years, around 1200 BCE, in what historians call the Bronze Age collapse. Entire ways of life, gone in a generation or two. And here's what's crucial. The people living through these collapses didn't understand what was happening to them. They didn't see it coming. They believed their civilizations were eternal, blessed by gods, destined to endure. They were wrong. So the question we need to ask ourselves, with all the honesty we can muster, is this: are we different? Are we the first civilization in human history that won't collapse? Are we the exception to a pattern that has held without fail for 5,000 years? Or are we just the latest in a long line of societies that believed they were special, that believed they were permanent, and that were proven catastrophically wrong? Let's look at the evidence. The archaeological record is unambiguous. Civilizations rise, reach peaks of complexity and power, and then collapse. The pattern repeats across continents and millennia. In Mesopotamia, the world's first urban civilization emerged around 5,000 years ago in the Tigris and Euphrates river valleys. The Sumerians built cities, invented writing, developed mathematics and astronomy, created complex irrigation systems, and established trade networks spanning thousands of miles. For over 1,000 years, Sumerian civilization flourished. Then it collapsed. The cities were abandoned. The irrigation systems failed. The population declined. Knowledge was lost. Why? Environmental degradation. The irrigation systems that made agriculture possible also caused salinization of the soil. Salt accumulated in the fields. Crop yields declined. The population couldn't be sustained. The civilization simplified rapidly. In Egypt, civilization persisted for 3,000 years, longer than any other complex society in history. The pyramids were already ancient when Cleopatra ruled. And yet, even Egypt collapsed. Multiple times, in fact. The Old Kingdom collapsed around 4,200 years ago. The Middle Kingdom collapsed around 3,600 years ago. The New Kingdom collapsed around 3,000 years ago. Each time, centralized authority fragmented. The economy simplified. Population declined. Cultural achievements were lost. Eventually, Egypt was conquered by outsiders and never recovered its independence or its former glory. The Roman Empire is perhaps the most studied collapse in history. At its height, Rome controlled the entire Mediterranean basin, parts of northern Europe, the Middle East, and North Africa. 50 million people lived under Roman rule. Roads connected distant provinces. Aqueducts brought water to cities. A common currency facilitated trade. Latin was spoken from Britain to Syria. And then it collapsed. The western half of the empire fragmented in the 5th century. The eastern half, the Byzantine Empire, endured for another 1,000 years but never regained Rome's former extent or power. And eventually, it too collapsed. The collapse of Rome was catastrophic for the people who lived through it. Cities shrank. Literacy declined. Long-distance trade ceased. Technological knowledge was lost. The population of Europe didn't return to Roman levels for 1,000 years. In the Americas, the Maya built one of the most sophisticated pre-industrial civilizations in history. They developed a writing system, advanced mathematics including the concept of zero, accurate astronomy, and architectural achievements that still astound us. Their cities housed tens of thousands of people. And then, during the 8th and 9th centuries, the classic Maya civilization collapsed. Cities were abandoned. The population declined by 90% in some regions. Massive construction projects halted mid-completion. The jungle reclaimed temples and palaces. When the Spanish arrived 600 years later, the descendants of the Maya had no memory of who built the ruins in the forest. On Easter Island, Polynesian settlers arrived around 1,200 years ago and developed a unique culture. They carved the famous Moai statues, some weighing dozens of tons, and transported them across the island. The population grew to perhaps 15,000 people, and then it collapsed. The islanders deforested the entire island. Without trees, they couldn't build boats. Without boats, they couldn't fish effectively. The population crashed to a few thousand. Warfare erupted. The statue building stopped. When Europeans arrived in the 18th century, they found an impoverished society living among the remnants of a vanished culture. The pattern is consistent across geography and time. Civilizations emerge. They grow in complexity. They reach peaks of achievement. And then they collapse. Not slowly, not gradually, rapidly. Within a few generations, complex societies simplify dramatically. This isn't ancient history, this is a pattern, and patterns predict. So what does this mean? It means that civilization is not a stable state. It's a temporary phase, a bubble of complexity that eventually bursts. And we're in one of those bubbles right now. Why do civilizations collapse? What's the mechanism? What causes these rapid simplifications? The most comprehensive answer comes from anthropologist Joseph Tainter, who studied dozens of historical collapses and identified a common pattern. Civilizations, he argued, collapse because of complexity. Here's how it works. Societies solve problems by becoming more complex. You need to feed more people, develop more sophisticated agriculture. You need to defend your territory, build a professional army. You need to manage resources, create bureaucracies. You need to coordinate large populations, develop writing and record keeping. Each solution adds complexity, more specialization, more hierarchy, more infrastructure, more systems that need to be maintained. And here's the crucial insight. Complexity has diminishing returns. The first increases in complexity are extremely beneficial. The difference between no writing and basic writing is enormous. The difference between no agriculture and simple agriculture is transformative. But as societies become more complex, each additional increase in complexity produces less benefit. The difference between basic writing and advanced writing is significant, but not as transformative. The difference between simple agriculture and intensive agriculture provides gains, but at higher cost. Eventually, you reach a point where increasing complexity costs more than it produces in benefits. You're running harder just to stay in place. You need more administrators to manage the administrators. You need more tax collectors to fund the tax collection system. You need more soldiers to defend your defensive infrastructure. The society becomes top-heavy, fragile, vulnerable to shocks. And when shocks come, droughts, famines, invasions, plagues, the overly complex system can't adapt. It's too rigid, too specialized, too dependent on everything working perfectly. So it collapses. Simplification happens involuntarily and rapidly. The bureaucracy dissolves. The trade networks fail. The cities empty. The population declines to levels that can be sustained with simpler organization. This happened to Rome. The late Roman Empire was staggeringly complex. Massive bureaucracy, professional army, sophisticated tax system, legal code covering every aspect of life. When that complexity became too expensive to maintain, when the benefits no longer justified the costs, the system collapsed. This happened to the Maya. They built increasingly elaborate cities, temples, and palaces. They developed complex agricultural systems to feed growing populations. They created hierarchical societies with specialized roles. And when environmental problems emerged, when droughts reduced agricultural output, the complexity couldn't be maintained. The system collapsed. The pattern holds across history. Complexity increases until it becomes unsustainable, and then simplification happens rapidly. Now let's pause here and consider what this means for modern civilization. We are the most complex society that has ever existed, not even close. The level of specialization, the extent of infrastructure, the density of information systems, the sophistication of technology, all unprecedented in human history. We have global supply chains spanning every continent. We have billions of people in cities dependent on food grown elsewhere, water pumped from distant sources, and energy transported across thousands of miles. We have technologies so complex that no single person understands them completely. We have financial systems of staggering intricacy. We have billions of people whose entire lives depend on systems they don't understand and can't control. This is complexity on a scale the Maya and the Romans couldn't have imagined. And if Tainter is right, if complexity inevitably reaches diminishing returns, if overly complex systems are fragile, then we are more vulnerable to collapse than any society in history. Hold that thought, because there's another mechanism of collapse we need to understand. Environmental overshoot. Civilizations don't just collapse because of internal complexity. They collapse because they exceed environmental limits. This is the thesis of Jared Diamond's work on societal collapse. Societies grow by exploiting resources. They cut down forests for farmland and fuel. They deplete soils through intensive agriculture. They overhunt and overfish. They divert water for irrigation. They mine ores and minerals. For a time, this works. The resources seem inexhaustible. The forests stretch for miles. The soils produce abundant harvests. The fish populations seem limitless. But resources are finite, and when you're using them faster than they regenerate, you're borrowing from the future. You're in overshoot. Your population and consumption exceed the long-term carrying capacity of your environment. This can last for generations, sometimes centuries. As long as there are still forests to cut, soils to deplete, fish to catch, the society continues. But eventually, you hit the limits. The forests are gone. The soils are exhausted. The fish are depleted, and the carrying capacity drops suddenly and catastrophically. The population that was sustained during the overshoot phase can no longer be sustained. Famine results, social order breaks down, the civilization collapses. This is what happened to the Maya. They exceeded the carrying capacity of their tropical environment. They cleared forests for agriculture. They built massive stone cities, but tropical soils are fragile. Without forest cover, they erode quickly. Agricultural productivity declined, and when droughts hit, the system couldn't recover. The population crashed. This is what happened on Easter Island. The islanders cut down every tree on the island. They needed wood for boats, for transporting the moai, for fuel, for construction. For generations, this seemed sustainable. But trees grow slowly, especially on a small, isolated island. Eventually, the last tree was cut. And without trees, the civilization couldn't function. Food production declined. The population collapsed. This is what happened to many civilizations. They grew beyond sustainable limits, borrowed from environmental capital rather than living on environmental income, and when the capital was exhausted, they collapsed. Now let's talk about modern civilization. We are in massive environmental overshoot. Not local overshoot like the Maya or the Easter Islanders. Global overshoot. We're depleting topsoil faster than it forms. Agricultural land is losing fertility worldwide. It takes centuries to build an inch of topsoil. We're losing it in decades. We're depleting aquifers faster than they recharge. Major agricultural regions depend on groundwater pumped from ancient aquifers. The Ogallala Aquifer beneath the Great Plains, the aquifers beneath northern India and China, all being drawn down at rates far exceeding recharge. When they're empty, the agriculture they support ends. We're depleting fish stocks faster than they reproduce. 90% of large fish are gone from the oceans compared to pre-industrial levels. Many fisheries have collapsed entirely. We're destroying forests faster than they regrow. The Amazon, the Congo, Southeast Asian rainforests, all being cleared at rates that far exceed regeneration. And most critically, we're destabilizing the climate system itself. We're releasing greenhouse gases that have been locked underground for millions of years. We're changing the composition of the atmosphere. We're warming the planet faster than at any point in the last 65 million years. This isn't speculation. This is measurement. This is data. This is physical reality. We are exceeding planetary boundaries. We are in overshoot. And history tells us what happens to civilizations in overshoot. They collapse. The difference is that previous collapses were local or regional. The Maya collapsed, but civilizations elsewhere continued. Rome fell, but China thrived. Easter Island's collapse was tragic for the islanders, but irrelevant to everyone else. Our overshoot is global. There is no elsewhere. There are no unaffected regions. When global systems fail, everyone is affected. This is unprecedented, and it's terrifying. But there's a third mechanism of collapse we need to understand, one that's unique to modern civilization: the acceleration problem. Technology doesn't progress linearly, it accelerates. Each new technology enables additional technologies. The pace of change increases over time. It took hundreds of thousands of years to go from stone tools to agriculture. It took 10,000 years to go from agriculture to the Industrial Revolution. It took 200 years to go from the Industrial Revolution to nuclear weapons. It took 70 years to go from nuclear weapons to artificial intelligence. The intervals are shrinking, change is accelerating. And here's the problem. Human biology isn't accelerating. Our brains are the same brains our ancestors had 50,000 years ago. Our cognitive capabilities haven't changed. Our ability to process information, to make wise decisions, to understand complex systems, all unchanged. But the complexity of the systems we've created has increased exponentially. We're Stone Age brains trying to manage Space Age technologies, and we're bad at it. Think about nuclear weapons. We invented them in 1945, 80 years ago. In those 80 years, we've come close to nuclear war multiple times. The Cuban Missile Crisis in 1962. False alarms in 1979 and 1983, where computer errors nearly triggered launches. The 1995 Norwegian rocket incident, where Russian radars detected what they thought was an incoming missile. We've been extraordinarily lucky. Multiple times, individuals made judgment calls that prevented nuclear war. Soviet officer Vasily Arkhipov refused to authorize a nuclear torpedo launch during the Cuban Missile Crisis. Soviet officer Stanislav Petrov refused to report a false alarm as a real attack in 1983. Individual humans making split-second decisions under enormous pressure prevented the end of civilization. That's not a robust system. That's a fragile system held together by luck. And nuclear weapons are just one technology, one risk. We've created dozens more. We've created chemical and biological weapons capable of killing millions. We're developing gain-of-function research that makes pathogens more deadly, ostensibly for defensive purposes, but creating risks of accidental or deliberate release. We're developing artificial intelligence systems that might, within our lifetimes, exceed human intelligence in every domain. We have no idea how to control such systems. No theory of AI alignment that we're confident in. No way to guarantee that superhuman AI will remain aligned with human values. We're developing nanotechnology that could enable self-replicating machines. The benefits could be enormous. The risks include scenarios where self-replicating nanomachines consume the biosphere. We're editing genes with CRISPR and related technologies. The potential for curing diseases is real. So is the potential for creating designer pathogens or editing human germlines in ways that have unpredictable consequences. Every one of these technologies is being developed without adequate safeguards, without international coordination, without careful consideration of risks, because the incentives favor moving fast. Companies compete. Nations compete. The first to develop a powerful technology gains advantage. The cautious fall behind. So we race forward, developing capabilities that could end civilization, hoping that wisdom will catch up to power. History suggests it won't. And here's what makes this different from every previous civilization. Previous societies collapsed locally. Their technologies couldn't threaten the entire species. The Roman Empire fell, but humanity continued. The Maya collapsed, but the world endured. Our technologies are different. They're global in reach, and they're powerful enough to threaten not just our civilization, but our species. We're the first civilization capable of causing human extinction. That's new, and it changes the calculation. Let's be specific about the threats we face. Nuclear weapons were the first technology capable of ending civilization. We've had them for 80 years. We've never used them in war since Hiroshima and Nagasaki. But we've built 35,000 of them at the peak of the Cold War. We still have about 12,000. Enough to destroy every major city on Earth multiple times over. Enough to create a nuclear winter that would collapse agriculture globally and kill billions through starvation. The Cold War ended. The risk declined. But it hasn't disappeared. 9 countries now have nuclear weapons. The United States, Russia, China, France, the United Kingdom, India, Pakistan, Israel, and North Korea. More countries have the technical capability and could build them if they chose. The weapons still exist. The delivery systems still exist. The targeting plans still exist. A major nuclear war is still possible. Unlikely perhaps, but possible. And unlikely events happen eventually. If something has a 1% chance of happening per year, the probability that it happens within a century is about 63%. If it has a 0.1% chance per year, the probability within a century is still 10%. We don't know the actual probability of nuclear war, but we know it's not zero, and we know that the consequences would be catastrophic. Then there's climate change. We've increased atmospheric carbon dioxide from 280 parts per million before the Industrial Revolution to over 420 parts per million today. The planet has warmed about 1.2 degrees Celsius. We're on track for 2 to 3 degrees of warming by 2100, possibly more if feedbacks accelerate warming. This doesn't sound dramatic. A few degrees. What's the big deal? The big deal is that small changes in average temperature translate to massive changes in climate patterns. The difference between the last ice age and today is only about 5 degrees Celsius. 5 degrees was enough to put mile-thick ice sheets over North America and Europe. 5 degrees was enough to lower sea levels by 400 feet. 5 degrees redrew the map of the habitable Earth. We're changing temperature in the opposite direction at a rate 30 times faster than the transition out of the ice age. The consequences are already visible: more frequent and intense heat waves, more powerful hurricanes, droughts in some regions, floods in others, melting ice sheets, rising seas, coral reefs dying, ecosystems shifting toward the poles, and we're still in the early stages. The full effects of the warming we've already caused haven't manifested yet. There's a lag between emissions and impacts. We've committed to additional warming even if we stopped all emissions today. At 2 degrees of warming, which seems likely, we'll see the collapse of coral reefs, massive displacement of populations from sea level rise and agricultural disruption, and the beginning of feedback loops that could accelerate warming beyond our control. At 3 degrees, we're in territory that threatens the stability of industrial civilization. Agricultural systems fail in multiple breadbasket regions simultaneously. Water scarcity becomes critical in regions housing billions of people. Mass migration creates political instability. The economic costs become overwhelming. At 4 degrees and beyond, we're looking at scenarios where most of the planet becomes uninhabitable during summer months due to heat stress, where agricultural collapse leads to famines affecting billions, where the carrying capacity of Earth drops dramatically and suddenly. This isn't speculation. This is what the physics and biology tell us happens at those temperature ranges, and we're not stopping. Emissions are still increasing. Fossil fuel use is still growing. The curve isn't bending downward fast enough. Climate change alone might not cause human extinction, but it could cause civilizational collapse. It could reduce the global population from 8 billion to 1 or 2 billion through famine, conflict, and the breakdown of complex systems. And collapse makes us more vulnerable to other risks. Then there's artificial intelligence. This one is harder to assess because it hasn't happened yet. We don't have superhuman AI. We don't know when we will. Estimates range from 10 years to 50 years to never. But the trend is clear. AI capabilities are increasing rapidly. Systems that couldn't beat humans at chess 30 years ago now defeat world champions trivially. Systems that couldn't recognize images 10 years ago now outperform humans at visual classification. Systems that couldn't generate coherent text 5 years ago now produce content indistinguishable from human writing. The question isn't whether AI will become more capable. It will. The question is what happens when AI becomes capable enough to operate without human oversight, when it can design better AI, when it can pursue goals we specify but in ways we don't anticipate. This is the alignment problem. How do you ensure that a system more intelligent than you remains aligned with your values? How do you prevent it from pursuing your stated goals in ways that violate your unstated preferences? It's not an easy problem. It might not have a solution. And we're racing to build more powerful AI without having solved it. If we get it wrong, the consequences could be existential. An AI system optimizing for a goal we specified might pursue that goal in ways that are disastrous for humanity. The classic thought experiment. An AI told to maximize paperclip production might convert all available matter, including humans, into paperclips and paperclip-producing machinery. That's an extreme scenario. But the principle is sound. Powerful optimization processes can produce outcomes we don't intend and can't control. And we're building those optimization processes, right now, without adequate safeguards. Then there's biotechnology. We can now edit genes with precision. We can synthesize viruses from scratch. We can modify organisms in ways that were impossible a decade ago. The benefits are real. Gene therapy could cure genetic diseases. Modified crops could feed more people with less environmental impact. Synthetic biology could produce medicines, materials, and fuels sustainably, but the risks are also real. A modified pathogen could be more lethal than anything nature has produced. An engineered organism could outcompete natural species in ways we don't predict. A careless experiment could release something we can't contain. And the technology is becoming cheaper and more accessible. What required multi-million-dollar facilities 10 years ago can now be done in modest labs. What required specialized expertise can now be done by talented undergraduates. We're democratizing the power to create pandemics. We're making it easier for smaller groups, possibly even individuals, to create biological threats. The probability of a catastrophic bioengineered pandemic is unknown, but it's not zero, and it's probably increasing as the technology spreads. These are the new risks. The risks that didn't exist for previous civilizations. Nuclear weapons, climate change, artificial intelligence, biotechnology, each one capable of causing collapse, possibly extinction, and we're facing all of them simultaneously. So what does this mean? Here's where the logic becomes uncomfortable. Every previous civilization faced challenges: droughts, invasions, plagues, resource depletion. Some civilizations overcame these challenges temporarily, but eventually they all collapsed. We face challenges that are orders of magnitude more severe. Global environmental disruption. Technologies capable of destroying civilization in hours. Complexity beyond anything previous societies attempted. And we believe we're different. We believe we'll survive. We believe that technology will solve the problems technology created. We believe that human ingenuity will prevail. Why do we believe this? Not because of evidence. The evidence suggests otherwise. The evidence is a 5,000-year record of civilizational collapse. The evidence is that complexity reaches diminishing returns. The evidence is that environmental overshoot leads to crash. The evidence is that powerful technologies are dangerous. We believe we're different because we have to. Because the alternative is unbearable. Because accepting that we might collapse, that our civilization might be temporary, that our children might live through the end of the world as we know it is psychologically intolerable. So we deny it. We rationalize. We invent reasons why this time is different. Why we're special. Why the pattern won't apply to us. This is what every previous civilization did. The Romans believed Rome was eternal. The Maya believed their cities would stand forever. Every civilization believes it's permanent, until it isn't. So let's examine the rationalizations. The reasons we give for why we're different. Rationalization 1. We have science. Previous civilizations didn't understand the world the way we do. They couldn't measure or predict. We can. We understand climate change. We understand resource depletion. We understand complexity. Knowledge is power, and we have more knowledge than any society in history. This is true, but it's not sufficient. Understanding a problem doesn't guarantee solving it. We understand climate change. We've understood it for decades. We're not stopping it. We understand that nuclear war would be catastrophic. We haven't eliminated the weapons. We understand that antibiotic-resistant bacteria are emerging. We're not changing the practices that accelerate resistance. Knowledge is necessary but not sufficient. We also need wisdom. The wisdom to act on what we know. The wisdom to prioritize long-term survival over short-term gain. The wisdom to cooperate on a global scale. And we're not demonstrating that wisdom. Rationalization 2. We have technology. We can solve technical problems with technical solutions. Renewable energy can replace fossil fuels. Carbon capture can remove greenhouse gases. Genetic engineering can increase food production. AI can optimize systems to be more efficient. This is partially true. Technology can help. But technology is also the source of many of our problems. Technology gave us the weapons that threaten us. Technology enabled the resource extraction that's destabilizing the biosphere. Technology increased our complexity beyond sustainable levels. Solving technological problems with more technology is not guaranteed to work. It might. But it might also create new problems we haven't anticipated, and technology develops faster than our ability to understand its consequences. We're in a race between the problems technology creates and the solutions technology provides. There's no guarantee we win that race. Rationalization 3. We're global. Previous civilizations were regional. When they collapsed, others continued. We're connected now. We can share resources, coordinate responses, support each other. This is true, but it cuts both ways. Being global means that collapse, if it comes, will be global. There's no untouched region to rebuild from, no isolated population to carry on. If our interconnected systems fail, they fail everywhere simultaneously. Globalization creates efficiency, but it also creates fragility. A pandemic spreads globally in weeks. A financial crisis in one region cascades worldwide. A climate-driven agricultural failure affects global food supplies. We've sacrificed resilience for efficiency, and that makes us more vulnerable, not less. Rationalization 4. We're aware of the risks. We're monitoring the threats. We have institutions dedicated to preventing catastrophe. Previous civilizations collapsed because they didn't see it coming. We see it. We can prevent it. This is the most seductive rationalization and the most dangerous. Yes, we're aware. We have climate scientists, military strategists, AI researchers, bioethicists, all warning about risks. We have international organizations, treaties, regulations, all attempting to manage threats. But awareness doesn't equal action. We've been aware of climate change since at least the 1980s. We've done nothing sufficient to prevent dangerous warming. We've been aware of nuclear risk since 1945. We still have 12,000 warheads. We're aware of AI alignment problems. We're building more powerful AI anyway. Awareness is the first step, but it's not the solution. The solution requires coordination, sacrifice, and long-term thinking at a global scale. It requires overcoming the tragedy of the commons. It requires nations and corporations prioritizing collective survival over individual advantage. We've never done that. Not successfully. Not consistently. Not at the scale required. And there's no reason to think we will. So where does that leave us? Here's the logic, the Doomsday logic. Premise 1. Every previous civilization has collapsed. Premise 2. We face greater challenges than any previous civilization. Premise 3. The mechanisms that caused previous collapses, complexity, environmental overshoot, technological risk, all apply to us with greater force. Premise 4. We are not demonstrating the wisdom or coordination necessary to prevent collapse. Conclusion. We will collapse. Not might. Will. The only uncertainty is timing. This is the Doomsday logic. Not a prediction of when, not a claim that it's inevitable in any specific time frame, but a recognition that collapse is the default outcome unless something changes dramatically. And nothing is changing dramatically. Emissions are still rising, nuclear arsenals still exist, AI development is accelerating without adequate safeguards, biodiversity is declining, topsoil is eroding, aquifers are depleting. Every trend that should be reversing is continuing. Every problem that should be shrinking is growing. We're on a collision course with physical reality. And physics always wins. Now there's a counter-argument. Maybe we're at a unique moment in history. Maybe we're in the narrow window between developing dangerous technologies and achieving the wisdom to control them. Maybe this century is the critical period, and if we can navigate the next few decades, we'll emerge into a stable, sustainable civilization that can endure for millennia. Maybe. It's possible. It's not impossible. Humans are capable of extraordinary things. We've solved problems before. We've overcome challenges. We've adapted. But the odds don't look good. Think about it from a probabilistic standpoint. Let's say there's a 99% chance we survive any given year without catastrophic collapse. That sounds pretty good. 99% survival rate. But compound that over a century. 0.99 to the 100th power is about 0.37, 37%. Less than even odds that we make it through a century without collapse if the annual risk is just 1%. And the annual risk might be higher than 1%. We don't know. But given the number and severity of threats, 1% per year might be optimistic. This is the Doomsday arithmetic. Small annual probabilities compound over time into large cumulative risks, and we're not reducing the annual risk, we're increasing it. So let's talk about timescales. How long does modern civilization have? We don't know. Nobody knows. Anyone claiming to know is lying or deluded. But we can make informed estimates based on the evidence we have. Climate scientists tell us that we have until roughly mid-century to reduce emissions dramatically or commit to dangerous levels of warming. That's 30 years. One generation. Nuclear strategists tell us that the risk of nuclear war remains non-trivial as long as the weapons exist, and they'll exist for the foreseeable future. The risk persists indefinitely. AI researchers tell us that transformative AI could arrive within decades. The alignment problem is unsolved. The risk grows as capabilities increase. Biologists tell us that the probability of an engineered pandemic increases as the technology becomes more accessible. The risk grows over time. Each risk operates on its own timeline. But they're not independent. They interact. Climate disruption increases the risk of conflict, which increases the risk of nuclear war. Economic stress from environmental degradation reduces our ability to invest in AI safety or pandemic preparedness. The risks compound. If you ask experts to estimate the probability of civilizational collapse within this century, you get a range of answers. Some say 5%, some say 20%, some say 50% or more. Those aren't comfortable numbers. Even 5% is terrifying when we're talking about the end of civilization. And those estimates are from people who are generally optimistic about human ingenuity and technological solutions. The true risk might be higher. So what's a reasonable estimate? Somewhere between 10 and 50% seems plausible. We're more likely than not to survive this century. But it's far from certain. It's a coin flip, or maybe slightly better odds. And if we survive this century, we still face the same risks in the next century, and the century after that. The risks don't disappear. They persist until we either eliminate them or they eliminate us. This is the long-term perspective. Over a long enough timeline, the survival rate for civilizations is 0, unless we're different. Let's examine what it would take to be different, to break the pattern, to become the first civilization that doesn't collapse. First, we would need to solve the climate problem. This means reducing global emissions to near 0 within a few decades. It means transitioning entirely away from fossil fuels. It means potentially deploying carbon removal technologies at massive scale. It means coordinating global industrial policy in ways we've never achieved. Is this possible? Technically, yes. Renewable energy is cheaper than fossil fuels in many markets. Energy storage is improving. The technology exists or is rapidly developing. But technically possible doesn't mean likely. It requires political will. It requires economic sacrifice. It requires every major nation to cooperate. It requires overcoming powerful vested interests. It requires sustained effort over decades. We're not on track to do this, not even close. Second, we would need to eliminate the risk of nuclear war. This means reducing arsenals to minimal levels or eliminating them entirely. It means establishing verification systems that all nuclear powers trust. It means maintaining those systems indefinitely. It means ensuring that no new countries develop nuclear weapons. Is this possible? Maybe. We've reduced arsenals from Cold War peaks. We have non-proliferation treaties. The infrastructure for cooperation exists, but eliminate the risk entirely. That requires a level of trust and cooperation that has never existed in human history. It requires nations to give up their ultimate security guarantee. It requires perfect compliance forever. That seems unlikely. Third, we would need to solve the AI alignment problem before we build superintelligent AI. This means developing theoretical frameworks for specifying human values precisely. It means creating control mechanisms that work even for systems more intelligent than their creators. It means coordinating globally to ensure that all AI development includes adequate safeguards. Is this possible? We don't know. We don't have the theory yet. We don't know if alignment is even solvable. And we're building more capable AI rapidly without waiting for the theory to catch up. The race between AI capability and AI safety is not going well. Capability is advancing faster. Fourth, we would need to regulate biotechnology globally to prevent misuse while allowing beneficial applications. This means monitoring who has access to dangerous technologies. It means controlling the spread of knowledge and equipment. It means detecting and preventing harmful experiments before they cause damage. Is this possible? In principle. But it requires unprecedented coordination. It requires balancing security against scientific freedom. It requires enforcement mechanisms that work globally, including in countries with weak governance. That's extraordinarily difficult. Fifth, we would need to solve the complexity problem. We would need to maintain our complex systems while somehow making them less fragile. We would need redundancy, resilience, and adaptability. We would need to avoid the trap of diminishing returns on complexity. Is this possible? Maybe. But it goes against economic incentives. Efficiency and resilience are often opposed. The market rewards efficiency. Resilience is expensive. Building slack into systems reduces profit. We would need to fundamentally change how we organize economy and society. That's a civilizational level change. It's never been done. Sixth, we would need to stabilize population at sustainable levels. We would need to reduce consumption in wealthy countries. We would need to restore the ecosystems we've degraded. We would need to live within planetary boundaries. Is this possible? Technically, but it requires sacrificing growth. It requires accepting limits. It requires distributing resources more equitably. It requires a fundamental shift in values away from consumption and towards sustainability. We've never done that at scale. Not willingly. Previous societies reduced consumption through collapse, not through choice. So what would it take to be different? It would take solving all of these problems simultaneously. Climate, nuclear, weapons, AI, biotechnology, complexity, and sustainability. All at once, within a few decades, with global cooperation, against powerful opposition, sustained indefinitely. That's the challenge. Does it seem likely we'll succeed? Be honest. Knowing what you know about human nature, about political systems, about economic incentives, about the difficulty of coordination, does it seem likely? If you're optimistic, maybe you'd say 30% chance. Maybe 50% if you're very optimistic, but probably not higher than that. Not honestly. And that means there's a substantial probability, perhaps 50% or more, that we fail, that we collapse, that our children or grandchildren live through the end of industrial civilization. That's the doomsday logic. Not certainty, but probability. And the probability is uncomfortably high. So what does it mean to live at the end? What does it mean to be alive at a moment in history when civilizational collapse is not just possible, but probable within our lifetimes or our children's lifetimes? This is not an abstract question. This is personal. This affects how we live, how we plan, what we value, what we teach our children. Some people respond with denial. They reject the evidence, minimize the risks, insist that everything will be fine. This is psychologically understandable. Accepting the possibility of collapse is terrifying. Denial is a natural defense mechanism, but denial doesn't change reality. It just prevents us from preparing for it. Some people respond with despair. They conclude that collapse is inevitable, that nothing can be done, that effort is pointless. They withdraw, focus on personal pleasure, avoid thinking about the future. This is also understandable, but despair is premature. Collapse is probable, not certain. The outcome is not yet determined. There's still a chance, however small, that we navigate the challenges successfully. Giving up guarantees failure. Fighting might fail too. But at least it gives us a chance. Some people respond with preparation. They move to locations they judge more resilient. They learn practical skills. They build communities. They store supplies. They prepare to survive collapse if it comes. This is rational. If collapse is probable, preparation makes sense. But preparation alone doesn't prevent collapse. It just helps you survive it. And survival in a post-collapse world might not be pleasant. The best response, the only response that offers hope of avoiding collapse entirely, is action to reduce the risks. This means political action. Voting for leaders who take existential risks seriously. Supporting policies that address climate change, nuclear disarmament, AI safety, and pandemic prevention. Pressuring governments to act. This means personal action. Reducing your own environmental footprint. Supporting organizations working on these problems. Educating others. Spreading awareness. This means career choices. If you're young and choosing what to do with your life, consider working directly on these problems. We need climate scientists, AI safety researchers, biosecurity experts, policy specialists, communicators. We need people dedicating their talents to reducing existential risk. None of this guarantees success, but it improves the odds. And improving the odds is all we can do. There's a concept in risk analysis called the expected value. It's the probability of an outcome multiplied by the value of that outcome. Even if the probability of success is low, if the value of success is high enough, the expected value of trying is still positive. Saving civilization has infinite value. Even a 1% chance of success justifies enormous effort. So we should try. Not because success is certain, but because the alternative is unacceptable. There's also something else. Something harder to quantify, but perhaps more important. If we are living at the end, if we are the last generation, or one of the last generations of industrial civilization, then we have a responsibility to live well, to create beauty, to seek truth, to treat each other with kindness, to preserve what's worth preserving, to document what we've learned, to leave a record for whoever comes after, whether that's a renewed humanity or some other intelligence entirely. We're the ones who got to see the world before the fall. We're the ones who knew what it was like when the systems worked, when global civilization functioned, when you could travel anywhere and communicate with anyone. If we're the last to experience that, we should remember it, honor it, grieve it properly when it ends. But also, we should remember that humans have survived collapses before, not civilizations. Civilizations collapse, but humans persist. When Rome fell, people continued. When the Maya collapsed, their descendants continued. Life went on. It was harder, simpler, more brutal in many ways. But it went on. If our civilization collapses, that will be true for us too. The survivors, and there will be survivors, will rebuild. They'll adapt. They'll create new forms of society. They'll pass on what knowledge they can. Collapse is not extinction, it's transformation. Involuntary, tragic, but not total. That's the hope, if there is hope. Not that we avoid collapse, but that we survive it. That humanity continues in some form. That the story doesn't end with us. Let's return to where we began. Every civilization that has ever existed has collapsed. We've explored why, Complexity reaches diminishing returns. Environmental overshoot leads to crash. Technological power outpaces wisdom. The patterns repeat across history. We've examined the evidence, archaeological records, historical accounts, the consistent pattern of rise and fall. We've looked at the specific threats we face: climate change, nuclear weapons, artificial intelligence, biotechnology, risks that could end not just civilization, but possibly our species. We've considered whether we're different, whether this time is unique, and we've concluded that probably we're not. The same mechanisms that collapsed previous societies apply to us with greater force. We've done the arithmetic, the doomsday logic. The probability of collapse within this century is substantial. Perhaps 10%, perhaps 50%, perhaps higher. And we've asked what it means to live with that knowledge, how we should respond, what we should do. There are no easy answers, no comforting certainties, no guaranteed solutions. But there are choices. We can deny reality or accept it. We can despair or act. We can prepare for the worst or work to prevent it. Ideally, both. And there's something important to understand. Even if collapse is probable, even if the odds are against us, the outcome is not yet determined. We are not passive observers. We are participants. Our choices matter. What we do in the next few years and decades will determine whether we're one of the civilizations that collapses or one that endures. The odds may not be good, but they're not zero. And as long as there's a chance, however small, we have a responsibility to try. Not for ourselves necessarily. We might be fine. The early stages of collapse might not affect those of us living in wealthy countries significantly. We might live comfortable lives and die of old age while the systems slowly fail around us. But for future generations, for the children being born today who will live through whatever comes, for the potential of humanity that might be extinguished if we fail, we owe them the effort. We owe them the attempt to be different, to break the pattern, to become the first civilization that looked at the evidence, understood the risks, and changed course deliberately rather than collapsing blindly. Maybe we'll succeed. Maybe we'll solve the problems. Maybe this will be remembered as the century when humanity matured, when we transitioned from a fragmented collection of competing nations to a unified civilization capable of long-term survival. Maybe, or maybe we'll fail. Maybe future archaeologists, human or otherwise, will excavate our cities and wonder what we were thinking. Wonder why we saw the collapse coming and did nothing. Wonder why we prioritize quarterly profits over long-term survival. Wonder why we built weapons we knew would destroy us. Wonder why we kept extracting and consuming even as the systems failed. They'll find our records, our warnings, our scientific papers documenting the risks, our films and books imagining the end. And they'll wonder why we knew and yet continued. We can't know which future is real. We can't know if we're the generation that saves civilization or the generation that presides over its collapse. But we know this: the story is not yet finished. The outcome is not yet determined. We have agency. We have choices, and those choices matter. Every civilization that has ever existed has collapsed. But maybe, just maybe, we can be the exception. It's unlikely. The odds are long. The challenges are immense. But it's possible. And possibility is enough to justify the attempt. Because the alternative, accepting collapse as inevitable and doing nothing, is worse than trying and failing. We are living at a hinge point in history, a moment when the trajectory of civilization will be determined for centuries to come. Either we navigate the challenges successfully and endure, or we fail and simplify. We don't know which it will be, but we know what we should do. We should fight with everything we have, with all the intelligence, creativity, and determination our species possesses. We should fight for survival, for continuity, for the possibility that our children and their children might live in a world that works, not because success is guaranteed, but because it's the right thing to do, because we are the generation that has to decide, and how we decide matters. Every civilization that has ever existed has collapsed. Will we be different? Maybe not. Probably not, but possibly. And that possibility is worth everything.